Hi guys, this is Jawad. I'm coming back with a new video about unit testing. So let's go to the presentation and switch there. Right. Um, I'm gonna talk about unit testing code and specifically in Java. And it is a beginner level, so it's not going to be too difficult to follow, I hope. And it's going to explain a bit more about the dynamics of unit testing and what it could be and what it should be. So this is for software developers mainly, level entry beginner, as I said before, and or anybody actually interested in testing code. You're welcome to watch. And yeah, so let's go to it. Agenda is a bit of an introduction and then a bit about unit testing specifically and a live example. So what unit testing is a way for you and I to be able to guarantee a certain functionality inside the application. So if you write something and you're going to deliver to your end user, customer, or whomever is going to be benefiting from your great skills, need to know that they got something that works, and you need to know that you have delivered something that works, and unit testing do that. So you're going to test small bits and functionalities of your application in order for you to guarantee then when you change something that your unit tests are still guaranteeing that functionality, and otherwise if they do fail then it is because they are supposed to fail. So the value of your unit tests mostly is guaranteeing your software is of a valid quality, it's delivering the functionality you promised, and if you change something and you do something wrong, then they break and they tell you, oh, you have to be careful there, something went wrong. So it's a bit of a reminder for your the value of your code. The risks of not testing are actually the inversion of having a guarantee. So your code will have value if it's guaranteed. If it has no guarantees, then it has also no values. People will buy it, will work today, but it might not work tomorrow. And thus,
People are less inclined to pay for your great skills and software that you deliver.
so unit testing is saying something. So what's a unit? It could be a block of code. It could be a method, a function, a class, a component, a module. It could be anything. So a unit is not really defined until you define what it is. So I'm going to talk about the smallest unit that we are using, which is a single responsibility unit like a method or a class. And a class could have multiple functionalities, and thus yeah, let's go and look at the smallest part, which is in this case bits and pieces that you can isolate and test within a class. And going to switch to full development mode. So today's test case is about a dog, a very nice small dog that likes to sing and make sounds. And we're going to take it as a test case and how to model stuff and test it. See, in this case, this little dog likes to make a sound, like many of the dogs do. And I created for this instance a dog, and this dog makes a sound. And I see that I had some clutter code from before. So this sound, we give it to the dog and it will make it. The good programmer that I am, it takes an interface instead of an implementation, and this interface does have one method, and this method is make sound. So an implementation for the dog is dog sound, that implements the sound, that has the method overridden make sound, that gives barking. So this happy dog was doing this, and yes, he found the sound, he was barking, and he was happy. Dog makes barking sound. Fantastic. But as the years, days, weeks, millennia, no, that's too much. As the years went by, this dog was sitting on the veranda one day, saw the big white moon, and suddenly he discovered a new urge. He looked at the moon, got very big white eyes, and started to fill his lungs with air and started to do "Aroo!" He was no longer happy with just barking. He wanted to do howling. Well, fantastic. But this dog already could bark. Now, before I continue, I wanted to make sure that my code is doing the right stuff. Otherwise, it's going to be messy. It's not going to be guaranteed that it's going to do the same things that we wanted to do. So here's what I did. I made a test. So this test, lazy developer that I am, we don't have that many implementations, so it's very easy to test everything like in one time. I'm gonna do it in a very straightforward way. So I'm gonna say, okay, so dog type, dog variable is a new dog, and this new dog has a new dog. I wrote something new dog sound. Fantastic. So when I do this, I'm expecting the sound that my dog will make to be also, let's check it, barking. Okay, so I'm gonna copy barking. I know this is what my dog's gonna do, so I'm gonna assert it. And that way I'm going to test two classes at once. Fantastic, less work for me, happy me. Assert that, dog, oh, yes, so that dog dot get sound will result into a string that is equal to barking. This is crazy, a dog that barks, who would have thought? Anyhow, so this is the sound that it will make, right? Does it work? It works. Let's see the coverage. And let's do replace the current. Oh, look. So apparently it covers this, like a method, 100% line coverage for all of these, but it's okay. I was hoping actually it would also cover the dog sound in one time, but all right. Well, it is doing what it's doing. But now I'm gonna go and make a new sound. So this sound we're gonna change, right? So now we wanted to make a new sound that makes it happy. Howling. Right, so you can guess what's gonna happen next, right? You know what's gonna happen. I know what's gonna happen. Our test failed. He was expected to bark, now it's howling. Ay, 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 ay. Here's the thing. Dogs can make both sounds. So I'm the good developer that I am, because I already implemented an interface, I can just make another one. Instead of changing one and breaking the old ties, copy, paste, yeah. So, dog howling sound, right? So I created this one, it does howling, and this one I'm gonna go and revert back to its barking, and yes, now we have a howling sound. Okay, so go back to this and then say it's now howling. Oh yeah, no. So new dog howling sound is what we need. Okay, run, test everything. Yes, Eureka. Let's do it with a coverage. Yes. Add. Cool. Nice. Now, well, that's nice, right? Now we're testing everything's fine, and I am not very happy because now see, howling, like is it a start of a sentence really, or is it just a sound? You know what, I'm gonna make it like small letters, both of them, the howling, barking as well, and well, give it a better name here. Barking. Cool. Yeah, no, perfect. But if I run the test, oh no. So, but wait a minute. Dog was unchanged. I just changed the barking and the howling. Why did dog test break? Well, that's because I'm not testing it very well. This test is not really testing dog, it is testing its dependency, which is sound, or the sound implementation in this case. So that's bad. See, every time I'm gonna change something outside of the class, things will go wrong. My build will fail. Yeah, so this is not a situation we want to have. If you're doing code changes in the class and the class's test failed, that's perfectly fine. But if you change something else elsewhere in the application and your class's test is failing, then you're doing something wrong, because that means you're not testing your class, you're testing somebody else's class, and that could lead to disaster. And then you need to go and find in which class is it going wrong, and that's just a bad practice. So how are we going to test this class, right? Well, instead of like we can do a few things. Here we are putting an actual implementation of a different class inside that has its own dependency, that has its own behavior, and that dependency's behavior is actually producing a certain string. We do not really want that. I want to test that dog is calling upon the sound to get the right variable, and I don't really care what the variable is. So we're going to do it differently this time. Instead of giving an actual implementation, we're going to put in a mock. So we're going to say, we're going to enable Mockito framework. And the Mockito framework is a mocking framework that is used in tests. And mocking means it creates a fake object of the class that you assign to it, and then you can do a few very handy things. One of them is mocking its behavior. So mocking its behavior meaning, like, if we call a certain method inside a mock, then you can actually tell the mock what to do instead of having a strict behavior, like an implementation of dog howling sound. So, or you can monitor if a method within the mock is being called. So these things are handy in our case, and I'll show you how. This is interesting. So we're gonna say final var of the type sound is mock, and then we say sound dot class. No, let's see. Import static method and import class. So instead of actually creating an instance of the sound, we're gonna put a sound mock here. Let's give it a right name here. Mock. It's a sound mock object. So this sound object, we know what dog is going to do with it, right? So it is going to call upon make sound when we say get sound. So this is going to call this and return its value. Now we have full control of this mock, so we can say when sound mock dot make sound, then return sound. Right, so now we know exactly what this will return, and it's not going to be howling. It is going to be sound string. Right. So we know it's going to return the sound string. That's what it is going to do, because we instructed it to do so. And then you think, okay, but what are we doing really? Are we testing the mock? Well, you're completely right. I'm just checking that dog is still doing what it's supposed to do. And I can also just do the following. I say use mockito's verify, which verifies if a method is called, and say sound mock dot make sound has been called. So verify that the mock called mock sound is going to be called upon to make a sound. That's it. Let's see if it does what it does. And yes, replace active suite. So now we know that this one is being called, and we are verifying that everything has been called upon in the right order. Our test is not failing, it is doing what it's supposed to do. We can also be sure that dog is doing all that it's supposed to do without having to rely on the implementations. But that doesn't mean that we are exempt from creating tests for these implementations. We have to create tests for the implementations as well. So that everything is being tested. So we're going to go to the test.
The barking, and we know exactly what it does. So we saw assert that new barking, dog barking sound dot get dot make sound dot is equal to, and then barking, because we changed it all to small letters. And let's run it. And voila. One more plus is 100% covered. And the other, we'll make another one. And assert that
new dog howling sound dot make sound is equal to howling. Can test it. Everything has been called upon and tested, and our dog test is no longer reliant on the other two tests or the other two classes to test itself, which means that it is impervious. Anything we change here will only affect, so let's say barking, we're gonna remove those special characters, and only one test will now fail. And not all the tests, because in the previous situation, everything was failing. Now only just the specific test is failing for the barking, because they say, oh, it's a bit different than it was. But not everything else is failing, which is what you want to have in your unit testing. So this makes for much better tests. Don't you agree? What we take from this is make your tests small. Do not get very big units. Small units, so small units of code will make for a healthier heart that does not get a stroke while testing. It's fantastic. So enjoy testing. If you have any kind of ideas on what to improve this testing session, please let me know and I'll try to make a new video with your feedback. And I know this wasn't like the most genius big set of code for unit testing, but it was really about making tests in a small units that are responsible for very little and not testing outside of the class. So always test what's in the class and as small part as possible, and give each single class and unit its own tests. That way you can monitor these small parts instead of the holistic approach of testing the whole program in one big test, because these tests tend to be less readable and less maintainable, and even if there's a bug, it's harder to find. I will leave also the example code I just created for you in the GitHub repository in the comments. Thank you for watching. Bye bye.